Hi, in this video, I will be showing you problem number 8 of chapter 11, section 3. Use the integral test to determine whether the series is convergent or divergent. Sigma, n varying from 1 through infinity, n cube times e to the negative n to the power of 4. Evaluate the following integral 1 through infinity, x cube times e to the negative x to the power of 4 dx. So let's see what integral test means. Integral test, suppose f is continuous, positive, decreasing on the interval 1 through infinity, and let f a sub n equal to f of n. 1. Integral 1 through infinity fx dx is convergent would mean sigma an or the series is convergent. Integral 1 through infinity fx dx is divergent, then sigma an, the series, is also divergent. In other words, whatever the behavior of the integral, the improper integral 1 through infinity fx dx is, that is same as the behavior of the series. Consider the function or the relating function to the series, which is f of x equal to x cube e to the negative x to the power 4. In other words, we are taking n instead of n, we are assuming the variable x here. So we are creating a function f of x. This function is continuous because it's a polynomial and exponential combination. It's continuous and positive on the interval 1 through infinity. We should also prove that the function is decreasing on the interval 1 through infinity. So either it is sometimes obvious, sometimes we have to apply the first derivative test. So let's consider the derivative of the function f of x. So we are going to apply the product rule, x cube times e to the exponent negative x to the power 4. So it is u times v type. So we are going to apply product rule for the derivative. So it is u times derivative of e to the exponent negative x to the power of 4 times derivative of negative x to the power of 4, that is negative 4x cube. So this part completes u times v prime. Then we are going to do v times u prime. So the derivative of x cube, that will be 3x square. So in these two, we can take the common factor out, which is x square times e to the negative x to the power of 4, x square times e to the negative x to the power of 4, which is common in both. Then we'll be left with negative 4x to the power 4, negative 4x to the power 4 plus 3. X square e to the negative x to the power 4 is taken out. Then you are left with, in this term, only 3 is remaining. This is x cube times x cube, which is x to the power of 4. But I am pulling out x square from it. So I am left with x to the power 4 and then with this negative 4. So we can write this as x square times 3 minus 4x to the power 4. So I am now grouping this and this. And then we have e to the negative x to the power 4, because you have an exponent negative that can be brought down, be written as e to the power of x to the power 4. So x square is always positive, e to the x to the power of 4 is always positive. So the sign of this f prime x depends only on the sign of this in the parentheses, 3 minus 4x to the power of 4, which obviously is less than 0 whenever x exceeds 1. Whenever x exceeds 1 or more, then this is going to be definitely less than 0. Even if you plug in x equal to 1, it is 3 minus 4, which is negative. So which is going to be less than 0 whenever x is more than or equal to 1. So that shows if the derivative of a function is smaller than 0 in an interval 1 through infinity, then the function is decreasing. This is by decreasing test. So by decreasing test, or I can say decreasing test, we can conclude f of x is decreasing on 1 through infinity. So we have already stated that it is continuous, positive. Now we are also proving that it is decreasing on the interval 1 through infinity. So it satisfies all the requirements of the integral test. Now all we need to verify is whether the improper integral converges or diverges. Now we'll evaluate the integral 1 through infinity x cube e to the negative x to the power of 4 d of x. So this must be done by substitution method. If you look at the exponent here, it is x to the power 4 and this is x cube. So the substitution u sub method would be the best method here. So let's assume x to the power 4 equal to u. Substitute u equal to x to the power 4. If you differentiate both sides, you get 4x cubed dx equal to du. Or if you divide both sides by 4, you get dx cubed dx equal to du over 4. So the integral would become, without the improper integral sign, if you just consider integral x cube e to the negative x to the power 4 dx, this would give us e to the negative u, which is this e to the exponent part. Then x cube dx, the remaining part here, x cube dx, can be written as du over 4. So du over 4. So we get 1 over 4. We can write this as integral 1 over 4 e to the negative u du. So if we convert this back to the original variable, it will be 1 over 1/4 negative e to the negative u, or it is negative 1/4 e to the negative u can be replaced by x to the power 4. So x to the power 4. So we can write this one as finally integral 1 through infinity, and this can be written as a limit as, so yeah, applying the improper integral techniques, limit as t approaching infinity, and we evaluated this integral already, which is negative 1/4 e to the negative x to the power 4 1 through t. So we are going to evaluate that between 1 through t, and t is approaching infinity because it's improper integral. We cannot just plug in infinity just like that. So it is going to be negative 1/4 outside. Now we are going to plug in t, the upper limit, which is negative e to the exponent negative t to the power 4, and minus e to the negative 1 to the power of 4, which is e to the negative 1. And then keep in mind we are allowing t to approach infinity. So it is t approaching infinity. So it is going to be negative 1/4. Then t is approaching infinity. So we have here e to the negative infinity. E to the negative infinity would be 0. Then 1 over e to the negative 1 can be written as 1 over e. So the value of the integral would be negative, negative, that makes it positive. So it is 1 over 4e. So the second part of this problem is asking us to evaluate this integral. So for that the integral value would be 1 over 4e, which is a definite value, which means that integral 1 through infinity, improper integral, x cube e to the negative x to the power 4 dx is a definite value here. So it is convergent. So does the series. So sigma n varying from 1 through infinity, the series is n cube e to the negative n to the power 4 also converges. So in this problem, when you do these kinds of problems, you have to state what test you are applying. In this problem, it already gives you the hint in the problem what test to apply here. And you state the test clearly, and also if there are any requirements for the test, then you establish all the requirements of the test. In this case, we established the function is continuous positive, and we proved by applying decreasing test, increasing decreasing test, we actually showed the function is the function f of x is decreasing. We proved all that over here, and then we evaluated the integral that turned out to be a definite value, and because it turns out to be a definite value, the integral is convergent, and hence the series is also convergent. You may want to show all the steps here.